the radius and this bends down by an angle theta. We can draw this picture. Let's consider this thickness to be d, small d. Small d is pretty small. It's a strip, so d will be much smaller than, for that matter, radius or L naught. Okay, so what can I say? I can say L2 by L1 equals, what is L2? The original length L0 1 plus alpha 2 delta t. If I heat it, thereafter it becomes like this. What is L1? L0 1 plus alpha 1 delta t. Can I say that? Also, L1 is nothing but the arc. This arc is r minus d by 2 theta. And L2 is r plus, this length is d by 2, r plus d by 2 theta. Is the RHS okay with you? R plus d by 2 theta upon r minus d by 2 theta. We have got this. This is geometrical relation. The first one is based on thermal expansion. This is just arc equals angle into radius. Alright. So, now let's do on this, let's do a complemento dividendo. On the right hand side, if I see this L0 anyway goes, forget about it, theta also goes. On the right side, I add numerator and denominator. Numerator plus denominator is 2r. Here I do numerator minus denominator, which becomes small d. Can I say that? Can you write similarly what will be there on the left side? I add up the numerator and denominator. On the top you get 1 plus alpha 2 plus alpha 1 delta t upon, if I subtract it, I get alpha 2 minus alpha 1 delta t. Can I write like that? Now this becomes 2, sorry, this is 2 plus alpha 2 plus alpha 1 delta t. Is it fine? Complemento dividendo applied to this bit. Now, as I said earlier, is this fine? Okay with everybody, this equation? Now, alpha 1 plus alpha 2, alpha is very small. Even if you multiply by delta t, that number is not going to be very big. This is 2 plus some little number, something like 0.001. So we ignore this. This is tending to 0. Denominator is also tending to 0, but you can't ignore it. 1 upon a small number is a very huge number. So don't ignore the denominator, we ignore the numerator because that is being added to 2. So we forget about 2. 2 plus that is gone. 2 and 2 cancel. So what do you get? You get radius equal to d upon alpha 2 minus alpha 1 times delta t. As you increase the temperature, radius decreases. To begin with, radius is infinity. More is the temperature increase, more is the buckle. The radius will become smaller and smaller. It will curl up more. That's the meaning of that's the idea of the bimetallic strip. R equals d alpha 2 minus alpha 1 delta t. Yeah, is it okay?
So can you please explain that expression L2 by L1, the very first one? How do you get r plus d by 2 theta?
This one? Yeah.
Yes,
Yeah, what's your name?
Sakshi.
Sakshi. Sakshi, look at this diagram. L2 happens to be the midpoint of the second rod. You can see that this is in blue, okay? L2 is this length. Is that okay, Sakshi?
Yes.
Now, what is the distance between this point, I'm keeping my finger here, and this point? Tell me. R, how much is this?
D by 2.
R plus d by 2
Yes.
into theta. That's what I've written there. R plus d by 2 theta. Likewise, what is this length L1? What is the gap between this point and this point? It is this much less. What is this point? R minus d by 2 theta. Is it okay?
Yes.
Sakshi, is it fine?
Yes, sir.
Yeah. and thereafter the component dividendo. Is it okay?
Yes.
This is the mathematical simplification and you get this result. Yeah, everybody fine with this bimetallic strip radius, how it is depending on delta T, alphas and small d. See, understand this, that if this d were very big, radius will also remain big. That's why we are not using bimetallic slabs, we are using bimetallic strip. What I have shown is like a slab. This is only a picture for us to communicate easily. These are very thin, it's a strip, so smaller the d, smaller will be the r. Smaller the r means more is the curl. We want it to curl. We don't want a big radius. We don't want it to remain straight. We want to curl it up. Okay? Got it?
Excuse me,
We move to
sir.
the next idea. Yeah, you have something to ask?
So if alpha 2 plus alpha 1 is negligible, then alpha 2 minus alpha 1 2 would be negligible. So why don't we take
Wait a minute.
that part only?
2 plus 0.001 is how much? 2.001. Now I divide this by 0.001. If I don't neglect any of that, this is 2.001 divided by 0.001, 2001. If I neglect it and then write it, the answer is 2000. If I neglect both of them, the answer is 2. 2001, if you express as 2000, that's allowed. 2001 you express as 2. Better not express anything. Is it okay? Are you getting why we are doing it? This is coming in the denominator. When denominator is a small thing, 1 upon small thing becomes a very large thing. So it is having a very large value, so you don't neglect it. Yeah, is that okay? So let me go to the next idea. Shall I? So now I'm going to use this idea in flotation, or let's say buoyant force. So let's see how thermal expansion plays a role in buoyant force. From the idea point of view, buoyant force is what? Buoyant force you have done is Vd rho Lg. Vd is the volume displaced inside the liquid, rho L is density of liquid, G is gravity. Now if you increase the temperature, what happens? The volume of the solid will expand. So it all depends on whether the solid is fully immersed or partially immersed. So maybe more liquid is displaced now. I'm saying maybe, it depends upon the situation what is happening there. This volume may increase. Density of the liquid will decrease, because when you heat up, density goes down. So two factors are opposing each other. One increases, one decreases. So as a whole, what will happen to this, we can't say directly. It all depends upon the actual values. So with this basic introduction, let us see and do this question. So I'm not saying anything in general. You will have to examine what happens to this and this. G will remain constant, don't worry. This is the question. I have a cube floating. A cube is floating. The density of the cube is rho S. Density of the liquid is rho L. Alpha for the solid is, S also means the solid, alpha S, and this is alpha L, not alpha L. Let me give you gamma L. This is the initial situation. What's the question? First question, what is the fraction of the immersed portion of the cube? Second question, after you increase the temperature by delta T, what is the new fraction immersed? Delta T should be how much such that the cube is just immersed?
Can we just use alpha instead of alpha S and gamma?
Yeah, we can use it, but let me kind of first of all tell you what it is. Yeah, what you are saying is you would like to use alpha S as alpha and gamma L as gamma. That's fair enough. Three parts of the question. Fourth part, what is d dash by d? If d is the initially immersed, this is a cube, okay? D is the initial immersed depth of the cube. This is D. D is not given as such, but I am interested in what is the ratio of the depths immersed before and after delta T. So these are the 4 parts. So first part, yeah, Sakshi, have you done the first part? Yeah, Sakshi, no response. What are you saying? How do we go about it? Do some loud thinking. What do we write? Why does something float? You did Archimedes principle, I believe. You did Archimedes principle. Why, when something floats, what is the equation? Why does something float? You are giving an answer like an 8th class student. Now you have done Archimedes principle. Tell me, why does something float? What is the force equation there?
The weight of the body will be then equal to the buoyant force applied.
Exactly. Weight of the body equals the buoyant force. Alright? So what will you say? I am talking about the fraction which is immersed. If the weight of the body, weight equals buoyant force, so we can say weight is volume into density of solid into G. Can I say that?
Yes.
The fraction immersed, if we say 2/3 is immersed or 3/5 is immersed, that means fraction immersed is FV. This is the volume displaced. F is the fraction which is inside. Do you know how much of ice is inside when it floats in water?
98%.
Yeah, that you must have, maybe you did that question. So FV into density of the liquid into G. Can I say that? So Sakshi, what is the answer for F?
Density of solid upon density of liquid.
That's it. Density of solid by density of the liquid. First part is answered. Alright. So let's move. First part had got nothing to do with thermal expansion. We were basically talking about the idea of buoyancy. Now the second part. When delta T increases, the physics of the situation will remain same. So your answer should be
Should be the same.
same answer, but we won't call it rho S, rho L anymore. We will say rho dash S, rho dash L. Can I? Dash means altered densities at the new temperature. Is it fine? So, what will be the answer for this? I'm creating some space here. We will just write it down again there. So, can you fill this up? So, rho dash S will be what? Soumya, what will be rho dash S?
So 1 plus
Huh?
alpha.
Rho dash S means what? The new density of the solid. That will be equal to the old density
1 plus alpha delta.
upon. Did you say upon or not? I don't hear you saying upon. Rho S by 1 plus gamma S delta T divided by rho L upon. This upon will go on top. 1 plus gamma L delta T. But we have to check what is gamma S and gamma L. Gamma S is not given to you. What is gamma S?
3 alpha.
So rho S and rho L, that will be equal to your original F. That is fine. This is rho S by rho L into gamma L is 1 plus gamma delta T and gamma S is 1 plus 3 alpha delta T. Can I say that? This is the new fraction. Now we cannot say whether this is more than the old fraction or less than that, because this is the old fraction. This value can be more than 1 or less than 1 depending upon the values of gamma and alpha, which we don't know right now. So this cube may go in, may go out, anything can happen. Yeah, is the second part okay? First part and second part?
Yes, sir.
So we can even write that as rho S into 1 minus gamma.
I know, but why are you insisting on that? That is the approximation.
More accurate.
Let it remain the way it is. What advantage are you going to get out of this by approximating it? It will look equally dirty, if at all. You are not going to get a better answer than this. So let it remain. Now, why are you creating an approximation there? Okay. And there's nothing wrong, no harm in doing it, but Do it when you find advantage in it. What is advantage right now? No advantage. If I have given a numerical question saying, I have given you the values of rho s and alpha, then I ask you to calculate, then use it. Okay? Third part of the question. Third part of the question is what? At what temperature does the cube get fully immersed? How do we do it? At what temperature does the cube get fully immersed?
This should be equal to 1 as in the...
That's it. That's all. That's all. Over. This should be equal to 1. Solve for delta t. Over. I don't even solve for delta t. I leave it. You can solve for it. No problem. If the cube is getting immersed, means the fraction inside the liquid is 1. And you can calculate delta t from here. So I leave it here. That's all. I'm going to the fourth part. See, understand the meaning of this is the D. The depth to which the cube is immersed. Cube will have the same length on all the sides. Some portion of that cube is immersed, which is D here. Suppose I increase the temperature. The new immersed depth is D dash. So my question is, what is D dash by D? Dash means after the temperature increases by delta T.
So we divide the rho dash s upon rho dash L divided by rho s upon rho L into 1 plus alpha delta T.
Sir,
Are you saying it is equal to f dash by f or something? Are you saying it is f dash by f? We found f in the first answers, f dash the second one. Are you saying it is f dash by f?
So not f dash by s. F dash by s. F dash will give me the volume of that submerged. From that
Let's find out the final answer. Don't confuse me.
So I am getting it as 1 plus gamma delta t upon 1 plus 2 alpha delta t.
Yeah, I wanted to hear the 2 alpha. That's right. I think your answer is mostly right. Okay. 2 alpha part is definitely there. I think it should be right. Let me kind of derive it and see. Yes, how did you approach, Surabhi? May I know how you approached?
I just so rho s upon rho L Vs is equal to L into As initially.
No. Don't tell me some equations. What are you doing? Give me the concept behind. What are you trying to balance?
The displaced volume will be equal to the area into the length displaced.
Yeah. So initially the weight is being balanced by the buoyant force. This will be equal to area into D into density of the liquid into G. The weight of the cube will be equal to volume displaced. Volume displaced is this. This is the original area of the cube. A naught. A naught is the original area of the cube into D is the original depth. Now, when you increase the temperature by delta T, does the weight change?
It remains constant.
Weight will still remain same. It is still floating. What will change will the area change?
Yes, sir.
Area will become more. How much will more?
A naught into 1 plus 2 alpha delta t.
And what about density?
It'll change P.
It becomes 1 plus gamma L delta T. Is it okay? Density becomes rho L by 1 plus gamma L delta T. It has become less. Area has become more. Now both these equations are same. Also I missed out the D dash.
D dash.
I haven't put the D dash. I'll put it here. This is D and this is D dash. Both these are equal. Just equate them and get your answer. So you get what? D dash by D equals 1 plus gamma L delta T by 1 plus 2 alpha delta T. That's the answer.
Yes, sir,
That's what you said. Okay?
Yes, sir.
That's fine. That's the answer to the fourth part. Liquids will increase in volume. Their increase in length has no meaning. So usually it is the practice to give alpha for solids and gamma for liquids, because gamma for solid can be found as 3 alpha and there is no meaning for alpha for liquid. Okay? Is this fine? Are you okay with all these 4 parts in this question? Let's move on. Now talk about a question where we'll be using the differential approximation. I'm taking the case of a pendulum. May I know the time period of a pendulum? Simple pendulum, how do you give a time period? 2 pi under root L by G. We say like that. Okay. So, what is the time period of a seconds pendulum?
2 seconds.
2 seconds, yes. It goes tick tock. The tick takes 1 second, and tock takes 1 second. So 2 seconds. So it goes like that. Now what happens is, see, this would more be like an historical question, because nowadays pendulum clocks, even ordinary clocks which are having pendulum, the pendulum has got no connection with the clock. They normally put a digital clock there, and if you want a pendulum, put a separate pendulum which goes on vibrating. It has no connection with the clock.